Hi, welcome to Crown Innovative Solutions. Hello everyone, this is Swara here from Crown Innovative Solutions, and I welcome you all to this interesting session, where we are going to see how we can predict house prices using machine learning. So without any further, let me quickly walk you through today's agenda. First off, we'll start this session by understanding what is machine learning, an introduction of machine learning. And then we are going to discuss what are the types of machine learning. Next we will understand the problem statement. And then we are understanding the exact workflow of the house price prediction project. And then we are going to discuss what are the various types of tools and frameworks that we are going to use. And finally we are going to get down to our hands-on demo. So when I say machine learning, these are certain bunch of statistical methods. These are bunch of statistical methods which rely on certain set of data which it analyzes, and which it actually converts it into a kind of function with the help of which it builds a model. When it builds a model, with the help of those model we are also able to make certain predictions out of that. And during this entire process of doing these few things, it essentially moves towards the phase of artificial intelligence. So in a sense, when it is able to make certain predictions using certain set of provided data, it embeds certain amount of intelligence which is artificially provided. It analyzes different patterns of data, which is provided during your training time, and from that particular training set of data, it actually works out a particular model which could be used to make further predictions on that. When it comes to machine learning, there are certain terms which you need to be very much clear about. They are smart enough to analyze the data just possible, they are smart enough to understand the patterns, and they are also smart enough to make a particular predictive function out of the training data, which is provided. There are only three types of techniques. These are supervised learning, unsupervised learning, and reinforcement learning. So in this video, we have the topic of predicting housing prices. And for that we are going to focus mostly on supervised learning. So when I say supervised data, it is essentially a labeled data. By understanding what exactly are we going to do in our hands-on demo. So to understand this, let's see what exactly is our problem state. You see over here we are supposed to find or predict the price of a house given various scenarios. The scenarios can be based on something like median income of a person, the age of the house, the number of rooms that are available, and what exactly is the population in that particular area. And we are also going to do some feature engineering, and what exactly this feature engineering means is like, let's say we are given this latitude and longitudes, right? But this latitude and longitudes are just numbers. We cannot use this latitudes and longitudes to predict out which city or which area the house is located at. But we have multiple Python libraries using which we can generate, or we can find out where exactly is this latitude and longitude. So we are going to basically use feature engineering to generate new data, and apart from that we are going to use our actual data set and predict the various prices that can be given out for our particular model. Alright. So what are the prerequisites that you would be needing over here? Well, there is not much that you have to know, right? This is anyone who have a basic understanding of Python, and who knows how to work around machine learning algorithms, how to use basic sklearn libraries, how to do feature extraction, and feature engineering. If you're someone who has no idea about what we are talking about, the links for all of these courses will be provided in the description box below. So now that we know what exactly we are going to do and what are the various prerequisites that you would be needing to perform or to work with this project, let's now understand what is the workflow that we are going to follow over here. So first off, we are going to collect our data, right? We can collect our data from various sources. We can say like Kaggle, we can say sometimes Keras, and sklearn also have the built-in libraries, so we can also scrape our website in order to get data. Apart from that, we have to pre-process our data. The raw data just cannot be used to our model. This is because there can be many uncertainties, and apart from that we have to normalize our data in order to get and optimize on an accurate result. Then moving ahead, we'll be doing some feature engineering in order to get some new data, in order to generate a new data, I would say, and in order to also to clean our data set. And then we are going to create a model. We are going to create model in 2 stages. In a stage 1, what we are going to do over here is create a simple model using our sklearn framework, and then we'll see what is the accuracy that we are getting. And then what we are going to do is we are going to try to use some hyperparameter tuning techniques such as random search CV or a grid search CV, and apply this hyperparameter tuning on our model, and see what result or what can we enhance in our application. And finally, what we are going to do over here, we are going to create a function which will take out any input from the end user, and then we can predict out the values, what number can be expected from a model. If you need a tutorial how to install Python and work around with machine learning and Python, you can just refer to any of our Crown Innovative Solutions Python videos. So in order to work with our data set, I'm going to use pandas, and apart from that we have NumPy and sklearn. Basically we use NumPy in order to work with them, any other mathematical computation, basically arrays, and apart from that we have SQL framework, using which we have many built-in libraries, where we can create our own models. So this is it about the tools and frameworks that we are going to work with today. Let's start with hands-on project. For this project I'm using Jupyter Notebook. To open Jupyter Notebook, open your command prompt and type Jupyter Notebook and click enter. It will redirect to your browser. To create new file, click on New, and select Python file. It will create the new file. This is our Jupyter Notebook. To rename the file, double-click on Title, and change the title. I will save as Boston House Price Prediction 01. So now we can start the programming for our house price prediction. So you can write the code in this code cell, or you can create a text cell where you can make some comments about your code, so what basically you are doing in that particular cell. First of all, we need to import the dependencies. The dependencies are nothing but the libraries and functions we will be needing for this use case. So I will make the text here as importing the dependencies. So importing the dependencies, you can press Shift, press Enter to run that particular cell and go to the next cell. So first of all, let's import NumPy as NP. So NumPy is very much useful for making arrays. So those arrays are called as NumPy arrays. And then we need to import pandas as PD. So pandas is useful for making the data frame. So pandas as PD, and import matplotlib.pyplot as plt. So matplotlib is very much useful for making plots and graphs. We need another library for plotting, which is Seaborn. Import Seaborn as SNS. Now we need to import sklearn on dataset. Sklearn is a very important machine learning library from which we will get few datasets and a lot of machine learning algorithms and other functions. So sklearn.datasets, through this datasets module we can get that Boston house price data. Now we need to import the function train, test, split. So this function is used to split our original data into training data and test data. So import sklearn.model selection, import train_test_split. And then we need to import our XGBoost regressor algorithm. So from XGBoost, import XGB regression. So you need to note all those capital letters in small letters. So import XGBoost from XGBoost. Import XGB regressor. And we need to import the matrix module from sklearn. This is useful for evaluating our model. So these are the dependencies we will be needing. So run the cell. As I have told you earlier, you can press Shift plus Enter to run the cell. So we have imported all the dependencies. Now we need to import the Boston house price data, so I'll create another text and I'll mention here that I am importing the Boston house price data source. So we will be importing our dataset from sklearn's dataset. So I'll create a variable for storing this data. Let's create the variable as house price data is equal to sklearn.dataset.load_Boston data. Okay, so that is the dataset we need. You need to mention the parenthesis here. So it means we are taking one instance of this data set, so you can press Shift plus Enter again. So this will load the data set into the source space dataset variable. And don't worry about warnings. So we can now print and see the data. Print house price data. So this is our data. So you can see a lot of values here. So these values are stored in the array called data. There are another set of values from here. So these are stored in the array called as target. So this target represents the price of the houses. So this target means the label of this data set, and this data represents all the other 13 features. So we have seen that tax and age label and so on. So this data has the values for all those 13 features, and target represents the 14th column, which is the price of the houses. Now we don't want this data like this, so we want this data to be more structured. So for that purpose we will be using the pandas data frame. So that is the reason why we imported the pandas library. So now we need to load all these data into pandas data frame. So I'll make a comment here. So if you precede your script with the Python interpreter, so you know interprets that we are making some comment about the code. So it is a good practice to include commands in your code to understand what you are basically doing. So loading the data set to a pandas data frame. So I'll create the name for this data frame as house price data frame. Data frame, the function for this is pd.dataframe. So I have imported pandas shortly as pd. That's why I'm using pd. So pd.dataframe. Once again, so data frame, here we need to mention the data which we need to load it. So we'll be loading this data array to our data frame. So for that we need to mention this dataset.data. So pd.dataframe in the parenthesis, I am including house price data.data. Now we need to mention another parameters as columns. So this columns is nothing but the name of all the features. So these are the feature names, so you can see in the last line here. So we have these arrays, so we need to include all those feature names in our first row of the data frame. First of all, let me show you what happens if I run without this column parameter. So a data frame is created. Now let's print the first 5 rows of our data. So print first 5 rows of our data frame. So for that you can use the function yet, so you need to mention this data frame name here. So house price data frame dot yet, this will print the first 5 rows in this data frame. So there is some indentation here, as you can see here we have not included the columns parameter. So what happens here? So we don't have the column names, so we just have the serial numbers as 0, 1, 2, 3. So we don't want that, we want this feature name to be in the first floor, right? So for that purpose we need to mention the column variables. So I mentioned columns is equal to, so we want this feature names arrays to be in the first column. So mention that here, so house price data most price data set, because this is in the variable called as house price data. So hence we are mentioning it here. So house price data dot feature names. So this will give the column names for it. So as you can see now we have the column names. So the important point to note here is we don't have the price column here because we have just imported this data. We have array, we have not imported this target array, which is the price of the houses. So we need to include or incorporate this price or target array with this data frame. So we will do that now. So add the target column to the data frame. So this target is nothing but the house prices, so I'll mention it here. So mention the data frame name, which is house price data frame z house place data frame, and we need to create a column as price. So price column, which is equal to, mention the data set here. So this is the data set we have, so we need to mention house price data dot target to load all these data. Okay, so house price data dot target. So I'll run this now. You can again print the first 5 rows. So as we know that this is the function for that. So I'll copy this here and run it now. You can see that the target column is also add as price. So but in the previous case we didn't have that target or price column, so we have included that column as well in this data frame. So now what we will do, we will check the number of data points we have. So number of rows and columns we have. So checking the number of rows and columns in the data frame. So for that you can use the function shape. So house price data frame dot shape. So this gives the shape as 506 into 14, which means we have 5 not 6 rows, which are 5 or 6 entries, and 14 columns. So including this price we have 14 column. So now what we will do is we need to check whether our data set has missing values. So if we have some missing values, we need to do some more processing steps before we feed the data to our machine learning algorithm. So we cannot feed data set with missing values directly to our model. So it will make our model not to work properly. So we need to check, is there any missing values? So check for missing values. So mention the data frame dot is null. So this is null function checks how many your null values or missing values are there. And if we mention this sum as well, this will count the number of missing values. So this will give the number of missing values in each column. So as you can see here, all represents 0. Okay, which means there are no missing values. So if we have missing values, we need to process the data with methods like dropping or imputation. So luckily in this data set we have all the data, so we don't need to do any processing. So in some other projects, I will be telling you how you can handle those missing values. So in this particular scenario, we don't have any missing values, so we can continue our step. Now we can get some statistical measures of this data, statistical measures of the data set. So statistical measures are nothing but the mean, standard, deviation, percentage, and many more. So mention the data frame name source, price data frame, dot, describe. So this will give the various statistical measures, as you can see here for each columns. We have the count, so a count represents the number of data points. Totally we have 5 not 6 data points, and the mean gives the mean value for this first column, and this is the mean value for second column, standard, deviation, minimum value, maximum value, on the percentage. Okay, so percentiles means like if 25% tell it represents 25% of the value or less than 0.082. So similarly 50% means 50% of the value or less than 0.256. So these are some important statistical measures. So this helps us to understand our data set better. Now we need to do some more data analysis step here. So for that purpose we need to find the correlation between the data. So I'll make a text here, understanding the correlation between various features in the data set. So let me explain what is meant by this correlation in a minute. So basically there are two types of correlation. They are positive correlation and negative correlation. So correlation basically represents the relationship between two variables. So in this data set, we have various features or various columns. So we need to find how these features are correlated with each other. Let's say for example, we need to check the correlation for first column and the zone value. So positive correlation means these two are variables, right? So in the positive correlation, if one variable increases, the second variable also increases. Let's say, if crim and zone are directly correlated. If the crim will increases, zone value also increases. Negative correlation, if one value decreases the variable, the another variable also decreases, so that is called as negative correlation. So we need to analyze this correlation value between various features in the data set. So totally we have 14 features, including the price. So let's understand that. So I'll create a variable called as correlation. So you can get the correlation data from here. So mention the data frame name here. So I was placed data frame dot core. So this will give the correlation data. Now we need to see this correlation data is stored in this correlation variable. So basically what happens, the function analyze all these values and find the correlation between all these are features. For example, the crim value will be taken, and it will be the correlation of crim mischief with all the other columns. So this is carried out for all the other columns as well. So let's now plot that correlation and understand this. Constructing a heat map. Heat map are very useful for finding this correlation between various columns or features. So constructing a heat map to understand the correlation. So for this purpose, we need to include plt.figure. So this plt represents mat.leap.py plot. So as you know, you can see here we have imported this matplotlib.matplotlib.py plot as plt and cborn as sns. So these two functions of these two libraries are very useful for making graphs and plots. So plt.figure. Now we need to mention the size of our plot. So for that we need to mention the parameter as peak size, which is equal to 10 into 10. It means 10 into 10 units, and we need to create a heat map which is sns.heatmap, and we need to mention several parameters. So we are creating the heat map for this correlation value, right? So we need to mention this here. So I need a C heat map for this correlation value, and there are other parameters as well. So let me complete this parameters value and tell you what this basically does. So C bar is equal to true, and square is equal to true, fmt is equal to 0.1 f, and it is represented as node is equal to true, and a node size and an underscore kws is equal to. So we need to mention the size as size is equal to 8, and C map color, which is the color of the graph, is equal to. Let's create the graph with blue color. There is some mistake. Let me check and solve. So let me run this cell and tell. So this will create the heat map for the correlation value. So this is the heat map. So as you can see here, we have plot this heat map for this correlation value. So we have found the correlation from this function dataframe.core. Now we have mentioned another parameters as C bar. So this C bar represents the color bar. Color bar is equal to true. So true means we want that color bar in the side. So this is the color bar, as you can see here. So it has various values starting from +1 all the way to negative values to -6, right? So plus values means positively correlated, and negative elements negatively correlated. So I have already explained you what is meant by positive correlation and negative correlation. So square, so we want all the values to be mentioned in a square, and the fmt means, you know how many float values do you want. So I have mentioned .1f, so it means like I want one value after the decimal point. So you can see here, there is one value after each decimal point. So if I give you 0.2f, there will be two values after the decimal points. So that's why we are using this fmt parameters. And it means annotations is equal to 2. So these are annotations. So you can see all these, you know, feature names and all the values inside this cell. So these are annotations, and here I have mentioned the annotation size, So if I increase the size here, the size will be increased, the size of this text and the numbers and characters will be increased. And CMap is equal to blue. I have mentioned the color of which I want the heat map to be. Now so the maximum value for the correlation is +1. So plasma once means both the values are equal. So if one value increases, the other value also increases. You can see here this diagonal as the value as 1 because both the values are same. So you can see here, we have crim here and crim near also. So the both of them are same values, and as you can see here, this is the zone values and zone values. So both the columns are basically same. This diagonal is dark in color, so dark color represents positive mode, positive correlation, and negative recommends least correlated or negatively correlated. So this diagonal doesn't significant for us because both the columns are same. So what we are basically doing is we are taking all the columns in one side in the y-axis and all the columns in x-axis. And we are checking how these are correlated. We have created the heat map. Now we need to split the data into data and labels. So here in this case the labels are nothing but the price of the data. So we need to feed this data and label separately to our machine learning algorithm, and through that it can find the pattern between the price and all these data, and this is how it is going to learn from the data. So now let's separate this data and label. So create a text as splitting the data and target. So target represents the price or the label in this case. So I'll create two variables as x and y. The variable x let's include all the data, and in y let's include all the prices. So let's mention the data frame. So the name of the data frame is house price data frame dot drop. So basically this drop function will drop a particular column. So here I want to drop this price data, this price column. So I would mention this data frame name here dot drop this price. So this will drop this column. So x is equal to house price data frame dot drop. Now we need to mention the column name here. So the column name is price, right? So price, and we need to mention the axis 1. So if you are dropping a column, you need to mention the axis is equal to 1. If you are dropping a particular row, you need to mention that the axis is equal to 0. Now we need to store all the labels in the variable y. So what we will do, we will mention the data frame name, so house price data frame, and we need to mention the column price. So this will store the value of the price column in the variable y. So I'll run the cell now. Let's try to print x and y. So I'm printing x and y. As you can see here, now in this data frame the price column is removed and this price column is stored in another variable y. Now we can do some more processing before we read the data to our machine learning model. So we have done some analysis on this data. So as we have discussed in our workflow, now we need to split the data into training data and test data. Splitting the data into training data and test data, we need to create 4 variables: x train, x test, y train, y test. So I will be giving this x train data to my machine learning model. So basically what I am doing is, so I have this training data and the corresponding label for this training data will be stored in this y train, and I have this test data. So this test data will be used to evaluate our model, and the labels for this test data is in this array. Now let's use the function train test split. So you can see in the top that we have imported this train test split function from sklearn model selection. So train test split, so here you can mention the x and y. So we hope you know that we have splitted the data into x and y. So x represents all the data on the 13 columns, and y represents the 14th column, which is the price. So we need to mention that here. So I want to split this x and y into training data and test data. So I cannot do it manually. So for that purpose we are using the train test speed. So we need to mention the test size. So test size is equal to 0.2. So 0.2 represents I want 20% of the data to be in the test data. So 80% will be the training data, and the test data will be point to point represents 20%. Generally we know having 10 to 20% of the entire data, stage data under 90 or 80% is training data. Here, I am taking the test data as 20%. Now we need to mention the random state. Random state is equal to 2. So you can represent any number as 2 or 3. So each value represents one kind of splitting. So what is the significance of this is, so if you use the same value 2 while you are doing this programming, your data will be splitted in the same way my data is splitting. So if you are using the value as 1, your value will be your data set will be splitted in a different way. So if you want to reproduce the code, if you want to reproduce how this splitting is done in the same way, you need to mention the same random state value. Now I have this xtrain and test to veteranoids. So what happens is, 80% of the value will be stored as training data. And this 80% labels the value for 80% of this data. So the labels of this data will be stored in ytrain and the 20% data will be stored in next test and the corresponding variables will be stored in this ytest. So it can be done with the function train, test, split. So we need to mention the x and y. So we have splitted the x and y here. So as data and price, so we are mentioning x and y here. And I'm mentioning the test size as 20% and the random state. So you can give any number for random. Now let's run this. Now let's see how many instances are in xtrain index test. So access the original data, say x explain x test. So let's see how many values are there. x.shape, xtrain.shape, next test.shape. So as you can see here in the original data set, we had 5 not 6 values, so which is the x, and in the xtrain, we have almost 80% of the data which is 4 not 4. And in the x-test we have 20% of the data which is 1 not 2. So this is how you can split the data. And now we need to train our model. So this is model training. So as I have told you earlier, we are using the XGBoost regressor model. XGBoost track does it. So this is the model we will be using. So this is a type of decision tree algorithm. So if I want to be more precise, this is a decision tree based ensemble model. So ensemble means be more, we use more than one models. So it's like incorporating one or two or more models together. So this is an example of that ensemble model. So and it basically a type of decision tree model. I cannot explain you all detail about what this model is made of and all the mathematical basis of this model in this video. So as this machine learning course progresses, I will be making separate modules for each of these, modules for all the machine learning models. So for example, I'll be making a module for logistic regression and another module, so that module may contain 4 to 5 videos about logistic regression and another module on linear regression, XGBoost regressor, etc. So in this case we are using XGBoost regressor, as I've told you earlier. So now we need to load this model. Loading the model. So I hope we have already imported the XG regression model. So we need to use here. So I'll create a variable as model. So let me name the variable as model. So model is equal to XGB regressor. So we have imported already. So mention the parenthesis. So this will load the XGB regressor model to this variable, which is named as model. So to this model we need to fit the training data here. The training data is xtrain. This fitting is nothing but the training of the model. So training the model with xtrain. So you can do that by mentioning the variable. So I have loaded this XGB regressor into this variable called as model. So model.fit. So this will train the model. So you need to mention the data on the label. So here the data is xtrain. So this xtrain basically contains the 13 features or 13 columns of the training data, and this test in contains the price value of those corresponding values. So we need to mention both the xtrain and test. So I will represent it here. So model.fit xtrain. So you can run this. So here the model will be trained, and these are the various parameters in which our models are trained. Now we can evaluate our model on how well it is performing. So this step is called as evaluation. We cannot use the accuracy score for regression problems. So in basically what we will do in accuracy score is we will check or count the number of correctly predicted values by the model and the original values, and we will subtract. Find the difference between both of them, but we cannot do that in the case of regression because all these are numerical values. So we cannot find accuracy score for regression problems. Rather we find the metrics such as R-squared error and mean absolute error. So let me show you how you can find those metrics. So before that we need to do the prediction. So I'll create a text here. Prediction on training data. So basically our model is trained on this X-train data and now I am going to use this model. So this model is now trained but I am going to give this X-train array alone. And based on this value our model should predict the value of Y-train. So once it has predicted it I will know, compare the error, I will get the error by comparing the prediction of the model and the original values. So now let's try to predict the price of the houses with this X-train value. So we are trying to get the accuracy for prediction on training data prediction. So for that you can use the function model.predict. So for learning for fitting the value with the model we have used the function fit. So for predicting we will use the function model.predict. So model.predict mention X-train, so this will know. So basically what happens here is the model will predict the price value, the house price value and store all these prediction to the variable as training data prediction. Now let me run this, so you can just print and see these values. So these are the values predicted by our model. These are the prices of the houses predicted by our model. So these are nothing but in thousands of dollars, like $20,000, $47,000 and like that. So now we can compare this predicted value with the original value, which are this Y-train. So while comparing this we can get the error made by the model, by comparing how close is the value predicted by the model, and the original values. So for the purpose, we will be using those evaluation metrics. First we will use the R-squared error. So in classification problem the common metric used for evaluation is accuracy score, and for regression problem it's R-squared error and mean absolute error. So there are also other errors such as mean squared error, under root mean absolute error, and all those things. In this project we will discuss about only two errors, which are R-squared error and mean absolute error. So I'll create a variable as score1, I'll get the error value and store it in this score1. So score1, now you need to mention matrix. So you can see here while importing our libraries I have imported sklearn.matrix. So from here we can this particular model. Matrix contains the function for R-squared error, mean absolute square error. We will be using those functions. So matrix.r2 square. So this will give the R-squared error for the original values, which is Y-train and training data prediction. So this training data prediction is the value of prices predicted by our model. And this Y-train is the original values. So this will basically give the error made by our model. What happens here is, so this matrix R2 square function will find the value, and this value from this regression is based on the variance between both of these values. It will give the R-squared value. Now I'll get another value, another error value, which is absolute error. I'll create another variable as score2. Here let's make the function matrix.mean absolute error. So I want the mean absolute error, and same way we need to mention Y-train and training data accuracy. So this will give the mean absolute error. So this will just find the difference between the original data and the actual prediction. So it basically subtracts all these values from its corresponding original values, and it will give a mean value. This will give the mean absolute error. This is our squared error. So now let's try to print this values. Print R-squared error as score1. So this value should be close to 1. If the value is around 10 or more than 10, that means our model is not performing well. So it can be 1 or near to 1, or it should be closer to 0. So if it is 0 means our model is performing perfectly and it is predicting the values perfectly. So lesser the value, more accurate the model. So that is the concept. Now here we will print the absolute error value that we have found in the score2. Mean absolute error, this is shortly called as mean absolute error, is given by score2. Let's run this and print the error value. As you can see here, the error R-squared error value is 0.99 and mean absolute error value is 0.0145. So it's not very much larger around. It's not around 5 or 10. So if the value is around 5 or 10, that means our model is not making good predictions. So here the value is pretty small, which means our model is performing really good. so we can get more accuracy and we get very less error values also, if we use more data and other models. So we use X-train boost regressor model because we have a very less sized data set, so we only have 5 or 6 data points, right? Typically in a machine learning projects, we will be having thousands and even lakhs of data, so more the data more accurate or more well. Our model performs a pretty good. Accuracy score values is not very much higher, so our model is working well. So you need to note another main thing here. We have made the prediction on the training data, but there is one more thing that is important. So we need to find the error value for the testing data as well, because the model already seen the value of training data but it didn't see the value for test data. So more than the accuracy or error value of this training data, prediction is more important. When it comes to test data, the test data values are more important than this training data, so I'll also create the error value for testing data as well, prediction on test data, because for evaluation test data value is more important, prediction on test data, so we can just copy these things, so we just need to change here as test data accuracy, so test data prediction. We have already splitted the test data CX test, so run the cell accuracy on the prediction for this data, so let's not print it. Now we need to find the error value for test data. I'll copy this and change the X test values, so score1 matrix.r square. So here we need to mention Y test because we are checking for the test data prediction here. Also avoid test and test data friction. So now we can run this and see, so it is almost similar to the value for training data. So our model is performing fine. For training data the R-squared value is 0.973 and in this case it's 0.87. So this is the prediction on test data. This means our modernist model is performing pretty good. Now what we will do is we will just try to plot and see the error values. So I'll create another cell layer. I'm going to visualize the actual prices on the predicted prices. What I'm basically trying to do here is I'm going to get the original value for prices, which is Y train, and the training data prediction, and I'm going to plot that in a graph to see how close these values are. So how close our model is predicted, for that we need to make a scatter plot. plt.square/scatter. We have the scatter plot function in matplotlib, plt.scatter. We need to mention the two at least, which is Y train and training data accuracy, because I am comparing those two values, the original prices of houses and the price predicted by the model. So plt.scatter, plt.xlabel, so this is just naming the x-axis and y-axis. So plt.xlabel, let's label the x-axis as actual prices, and let's label the y-axis, label this is the predicted price. We will try to plot these two values and see the closeness between them. plt.title, let's name this graph as actual price versus predicted price. plt.show. So this will print the graph. We are brought in plotting the scatter plot for Y train, the original value on the predicted value, and I am naming the x-axis as actual prices, and y-axis as predicted prices. And we are naming the graph as actual price versus predicted price, so we will get a scatter plot. As you can see here, this x-axis contains the actual price, which is Y train, and the y-axis contains the values predicted by the model, which is named as predicted. Data points are very close to each other, which means the value predicted by our model, which is in y-axis, is very much similar to the actual prices of the houses given in the dataset. So this is how you can visualize the closeness between your model prediction and the original data points. That's it for this video. Hope you learned something. The code link will provide in description box. If you have any doubts on this project, please comment on comment box. We solve your doubt. Thank you for watching. Please subscribe and share to your friends and click the bell icon for more videos. Thank you. Happy learning and get certified.